Okay, YouTube, in this video I'm going to introduce the concept of polynomial division as well as use a technique called long division, polynomial long division, in order to find the quotient that we're interested in here. So when we talk about division, let's go ahead and start with this. With polynomials, what we're really doing is we're saying, we've seen two polynomials, say some polynomial f of x and some other polynomial g of x. I've seen these things get multiplied, I've seen these things get added together, I've seen these things get subtracted, but what we're going to attempt to do in this video is divide them. Okay. So a few things that I want to kind of point out here. First of all is when you divide a polynomial by a polynomial, what we're going to do is we're going to get some new polynomial, as a matter of fact, and we'll just call this the quotient polynomial. And this is what I want to write down here. So this is our quotient. Okay, this g of x right here is our divisor polynomial, divisor. The thing that is being divided we refer to in a quotient as the dividend. And then we say what happens is sometimes we get a remainder. So we might have a remainder polynomial over the thing we were dividing by. But this thing right here, right there, this is the remainder. Okay, so what I want to do is I just want to kind of clear this up here really quickly. We've seen long division before. This would be something like if I took 100, say for instance, divided by 22. And I'd say, okay, well 100 divided by 22. Actually, let's do this. Let's do 100 divided by 12. No, let's do 100 divided by 9. That's, this will work better. So we say 9. We say 100 goes in here, but 100 is our dividend. So this is the same thing as 100 over 9. And what I want to know is, what does this come out to be? So really our division algorithm, I had somebody tell me this once, does McDonald's sell cheeseburgers, is the algorithm we use here with division, but it stands for divide, multiply, subtract, carry down, and then begin again. Okay. And what this is referring to are the steps we take when we do long division in this array format. So you notice we put the dividend on the inside and the divisor on the outside. And what we're really asking is, well, how many times does 9 go into 1? Or we could ask, what could I take times 9 to get 1? Well, there's nothing that does this. And technically, we did do our division just now. So by putting this number up top here and say it doesn't go in any times, then what we do is we take this and we now multiply by the number out front. So 0 times 9 is 0. We did our multiply. So the next thing we're going to do now is we're going to subtract this number off. So we say 1 minus 0 is 1. So we've done our subtraction. And where this carry down part comes in is when we carry down the next value here. So we carry down the 0, and then now we're going to begin again, except for instead of saying how many times does 9 go into this 1 right here, we're going to say how many times does 9 go into 10, which is 1, by the way. So we divided. 1 times 9 is our multiply. We say 10 minus 9 is our subtract. We'll carry down and we'll begin again. So I get 1 here again, and I say 1 times 9 is 9. 10 minus 9 is 1. And here's the deal. This is our remainder. Okay. So when we list a remainder this way, up here we say 11, but we'd say plus, we had 1 left over, and the thing I was dividing by was 9. So what we get right here is really this. We got some quotient polynomial, or some quotient here, 11, and then we say that this thing right here is the remainder. Okay. We're going to do the exact same process when it comes to dividing with polynomials. So let's go ahead and take a look at what this would look like in a polynomial instance. Okay, so for the first time we're saying let's take this 4th degree polynomial here. Let's divide it by this 2nd degree polynomial here. So let's start with satisfying one thing right off the bat. The fact is the thing that is being divided is the thing that goes on the inside of this box. So we say 2x to the 4th power plus 3x to the 3rd power plus 5x, plus 0x squared. Notice that we don't have any x squareds, plus 5x minus 1. So one thing I want to point out on this video is essentially this. You have to fill in any missing place values. So we say fill in any missing values. And we mean any missing exponent values. We'll fill in a 0 for their coefficients. And then on the outside of this we have the divisor, the thing doing the dividing. So we say x squared minus 2x plus 2. So now, we are taking all of this divided by all of this. So for the first time, what we're going to do is I'm going to kind of walk you through the steps here, but we're going to start by dividing. Now notice, this is kind of a different question to ask, but we say how many times does this, say, go into this very first thing here? And to answer this question, it's kind of a weird thing. So instead of saying how many times does it go into, another way of asking the same question, for instance, 8 divided by 4 is 2, but what we're really saying is when I say 8 divided by 4, what could I take times 8 to get this right here? So we'd say 8 divided by 4, what can I take times 4 to get 8 is 2. We could think about it this way, and so here's how long division with polynomials works. You're always going to focus on the leading two terms, and I'm going to ask this question. We say how many times does x squared go into 2x to the 4th? Now, instead of trying to figure this out with division, we'll just ask this in terms of a multiplication question instead, like we mentioned here. So we'd say, really, x squared goes into 2x to the fourth, however many times I would have to multiply this by something to get 2x to the fourth. So the question is, what could we take times x squared to get 2x to the fourth? And the answer is 2x squared. So we're going to put that 2x squared on top of our x squareds here, and once we get this right here, then we've done our divide. The next thing on the list is the multiply. So we're going to take this term right here, 2x squared, we're going to take it times everything out front. So if we took 2x squared times x squared, we get 2x to the fourth. We say 2x squared times a negative 2x is a negative 4x cubed. We say 2x squared times a positive 2 is 4x squared. So now we've done our multiply. Check. What we want to do next is we want to subtract this, but the thing is we are subtracting all of it. So this is always the best practice. Put parentheses around all of what you just found there and put a negative out front. And what we're going to do is we're actually going to put a negative 1, and we're going to say, well, instead, let's distribute the negative 1 through. If we were to do this, this would become positive out front, and then these would all switch their signs. So this is negative now, this is positive now, and this is negative now. So when we add these, we say 2x to the fourth plus negative 2x to the fourth. These should cancel. We say positive 3x cubed plus positive 4 more x cubed is 7x's cubed. And we say 0x squared plus a negative 4x squared is a negative 4x squared. So now we did our subtraction. So what comes next is our carry down. We're going to add this down here, and we're going to begin again. So this time, what we really want to know is this. Instead of how many times x squared, which is the leading term here, goes into 2x to the fourth, which was the leading term here, now I'm asking how many times x squared goes into this leading thing, 7x to the third. And again, remember, we could just ask, what could I take times x to the second power to get 7x to the third? So it looks to me, or it seems to me like a positive 7x would do the trick. We say 7x now, we've divided, let's do our multiply. 7x times x squared is 7x to the third. We say now 7x times negative 2x is negative 14x squared, and 7x times this 2 here is 14x's. Okay, we are taking away all of this, so we'll make this a plus so long as we flip these signs in here. And we'll add these straight up and down. So these cancel. We get negative 4 and positive 14 come out to be 10 of these x squareds. A positive 5 and a negative 14 come out to be negative 9 of these x's. And then the last thing we have to do is carry down this negative 1 and begin again. So now we're asking, how many times does this leading term, x squared, go into 10x squared? It goes in 10 times. So now 10 times this out front, 10 times x squared is 10x squared. 10 times negative 2x is negative 20x, and 10 times 2 is 20. So we are going to subtract all of this, distribute the negative here, negative, positive, negative, and so we'll add these. These cancel out. A positive 20 and a negative 9 is a positive 11 of these x's. A negative 20 and a negative 20 and a negative 1 is negative 21. So this thing right here, I want to make sure we point out what this is, but this thing right here is the remainder. So make sure that we label this. But the remainder thing is this. We found the quotient up top, and I'm going to label this, and I want you to label it too, but we say this is our quotient right here. This is how many times this expression here goes into this long expression right here. But we say plus some remainder, and the remainder was the thing that we got as a remainder over the thing that we were dividing by. And in this case, the thing we were dividing by is x squared minus 2x plus 2. So this, all of this right here, this is the quotient we were after. And that is how you carry out long division with polynomials. You just follow this division algorithm. Cheers.